Okay, so in this video, we are going to talk about geometric mean and right triangles. Now you can see I've drawn a right triangle here, and I've also drawn the altitude from the right angle to the hypotenuse. That's an altitude because it's perpendicular there. And that's created two other right triangles within the big right triangle. Now we've seen previously that all three of these triangles are similar. That means we can write the proportions that relate their sides to each other. Well, if we do that, then we will discover the equations that illustrate these two theorems right here. So let's look at this first theorem. The measure of the altitude drawn from the right angle to the hypotenuse, that would be AD in my drawing, is the geometric mean between the measures of the segments of the hypotenuse. Well, when you write that statement in proportional form, remember that the extremes were here and the means were here. Well, the geometric mean is going to be what I put right here. So we're going to put AD, because it says the altitude, which is AD, is the geometric mean between the measures of the segments of the hypotenuse. Well, BD and DC are the segments I've created with that altitude. And so one of those segments, we'll put BD, goes here, and the other one goes here. Now, when I rewrite this equation by cross-multiplying, I get that AD squared equals BD times DC, which means that AD equals the square root of BD times DC. And so this is my geometric mean equation that represents this first theorem right here. Now for the second theorem, the measure of a leg. Well, my right triangle, of course, has two legs. Let's start with AC. So the measure of a leg is the geometric mean. So this time I'm going to skip the proportional way to write this, and I'm just going to write it this way. AC equals the geometric mean, that means I'm going to take the square root, between the measures of the hypotenuse, well that's BC, and the segment of the hypotenuse that is adjacent to that leg. Well, the segment of the hypotenuse that's adjacent to AC is DC. So I have this statement right here. If I write this theorem illustrating using AB as my leg, then AB is the geometric mean between the hypotenuse, which is BC, and the segment of the hypotenuse adjacent to AB, but that's BD. So these are my geometric mean equations for this right triangle, three right triangle combination that's labeled this way. All right, so let's just create some room here and put some labels on this triangle so that we can work some problems that illustrate these two theorems. Now when you're working with geometric mean, of course you've got that square root in the equation, so very often you are having to simplify square roots. All right, so let's suppose that we have the altitude labeled as Y, this labeled as X, and then the entire hypotenuse we'll say is 25 units long. And then we'll say that this leg right here is 15 units long. Well, if I want to write equations to solve for X and Y, then first I'm going to write my equation for this first theorem up here, which would be this one. AD, which is Y, is equal to the square root of BD, which is X, times DC. Now I don't have DC labeled, but if this entire length is 25 and this much is X, then DC is going to be 25 minus X. All right, so there's an equation, but it has two variables in it. Let's write the other equation using the other theorem. Now, I have AB labeled here, so let's use the AB equation. AB, which is 15, is the geometric mean between BC, which is the hypotenuse, and it's 25, times BD, which we are calling X. Well, I can solve this equation for X and then plug that in to solve for Y. All right, so if I solve this one for X, I'm going to square both sides, and then I get 225 equals 25X. And when I divide by 25, then I see that 25 goes into 225. Think quarters and money. Okay, there are 4 quarters in a dollar. This is like 225, so that's going to be 9 quarters. So x goes in 9 times, or 25 goes in 9 times. So x is 9. When x is 9, then let's put that in right here. So for this equation, I'm going to rewrite it over here. Square root of, now I'm going to put my 9 right there, and then 25 minus 9 right here. So y equals the square root of 9 times. Now 25 minus 9 is 16. You do not want to multiply these together. It's so much easier to go ahead and simplify your square root the way it's written. Square root of 9 is 3. The square root of 16 is 4. So y equals 12. All right, let's do one more example. We'll erase all of these. And we'll put some different numbers, letters on our picture. Play this game again. Now, let's suppose this time that this side is, well, I'm going to erase these. I'm going to use red this time to label this. That might be the easier. This side is 20. This side is x. This side is y. And we'll assume that this entire length is 30. All right, well, this time, when we write our equations, okay, so x equals, x is the altitude, it's like AD, so x equals the square root of BD, which is y, times DC, which is 30, minus y. And then when we use the equation over here for AB, which is 20, is equal to the square root of, and then BC is 30, and BD is y. So I square both sides to solve for y. I get 400 is equal to 30y, and when I divide, then I get this nasty looking fraction. Well, that just happens sometimes, and so that's going to have to be okay. Well, let's put that in and solve for x. So x equals the square root of 40 over 3 times 30 minus 40 over 3. Now, I did this problem because I wanted you to see that you can have ugly fractions in these situations, but you have the math skills to deal with that. So we're going to say this is 40 over 3. Now, I need a common denominator here to subtract these, so I have to put this number over 3, which means I have to multiply it by 3. So this is going to be 30 times 3, which is 90, over 3 minus 40 over 3. So now I have the square root of 40 over 3 times 50 over 3. Well, I'm going to go ahead this time and multiply the 40 and the 50 because I get 2,000, and I'm going to break it up a little differently. And the 3's I'll go ahead and multiply because I think you'll recognize that a little easier if I do that. Now, you know the square root of 9 is 3. I didn't have to do that. Could have just pulled the 3 out. But the square root of 9 is 3. The square root of 2,000 can be written as the square root of 20, or the square root of 20 times the square root of 100. Now, I can take the square root of 100. 20 I can also break down into 4 and 5, and I can take the square root of 4. So 20 becomes 2 times the square root of 5. 100 becomes, the square root of 100 becomes 10, and I have this 3 on the bottom. So we see that then x is going to be 20 over 3 times the square root of 5. So these are the kinds of problems you'll be doing, and this is the kind of math simplification you'll be expected to perform.